IABF, first prize in National Big Data Championship, and best author in finance by cnx123.com. Sir has served on various committees and boards at NIT Jalandhar, IIB Mumbai, and ICCE Inter Alia. And he, sir, is a life member of the Indian Econometric Society and Indian Commerce Association and Indian Economic Association. Sir, we are really privileged to have a resource person like you today in our own FDP. We are very happy to have you with us, sir. And over to you, sir.
Thank you. Thank you, Professor Rajina, for generous introduction. And thank you, Professor Tiwari, for inviting me for this session. I'm really happy to be here. And first of all, I would like to, apologize for the delay that has happened, and I had to make around 166 people right now wait for me. I'm really very sad and sorry about it. So there was a family emergency, and it happened exactly 10 minutes before the session timing. And I was on the verge of requesting Professor Tiwari very, very reluctantly, what should I do? But then, somehow things were, taken care of, and I could finally make it, but I'm still very sorry for the delay. Okay, without investing much time in anything else, I think we can come to the topic. So the topic given to me is how to use R for research. Now, using R for research, that is not something which can really be covered in a span of, let's say, 120 minutes. Now, today, it's even less. So I was wondering that how I should proceed. So instead of talking about in depth about some research tool, I thought I can motivate people to, start training themselves on R and give them some kind of a demystification about what R is. So before I begin, I would like to know from the audience if you can type in the chat box. And before we proceed, please feel free to interact as much as possible, whatever time we have. Just one request, in case you have a query or you want to clarify some doubt, kindly raise your hand. The raise hand option is there, and then I can take your query. But before that, can you just type in the chat box how many of you have worked on R earlier? Or you can just raise hands maybe. So those who have worked on R earlier can raise hands. I will count the number of hands, and then I will know what proportion of this class actually knows about R. Am I audible to the class?
Yes, sir, you're audible, yes, sir.
So can you raise your hands? So no hands are getting raised. So shall I conclude that you have never used R?
No, sir, we have not.
You have not? Okay, I think one AIMT Greater Noida. So only one hand has been raised. So largely it seems that the R, platform or language has not been fine. So let's take our baby steps in what R is all about, and then take a demo of how it can be used for research. So I think I sent a message to all of you to download R and R Studio. That you have done? Can you raise hands? Have you downloaded R and R Studio? Okay, some people are raising hands, but only 3 people are raising hands. Yeah, okay.
Yeah, okay.
5, 6. So friends, see this. I'm getting an echo. I think somebody's mic is not off. Can you just switch off your mics? Can you switch off your microphones? Yeah. Okay. Thank you. Yeah. So guys, what we will do is, if you have not downloaded R, so this session will be actually not very useful to you. So how I plan to do this session is that you work along with me, so that you can familiarize yourself on how to really work on R. Yeah, so I can see that many people have downloaded R and R Studio. So I will straight away take you to the screen. Please open R Studio on your system, and I will also open it on my screen. So let me just share the screen. So I have just shared the screen. Is my screen visible? Can someone confirm?
Yes, sir. It's visible, sir.
Yeah, okay. So those of you who have never used R, and I hope you are able to open R Studio on your system also. So when you have opened it, please go to File like this at the top left and press New File, right? R script, New File, R script. So now your screen will start looking like exactly like mine. Of course, I have many things written here, which will not be the case with you, but it will start looking like this. So first of all, what is R? So R is a open source software meant for statistical computing, and since the time it was launched first, it has become one of the most popular softwares across the world, used by econometricians, mathematicians, scientists, researchers. Not Can you give me a minute, please? Yeah, 1 second, guys. Give me 1 second.
Sorry to interrupt, but there is an R compiler online, right? So we can use that instead of RStudio.
Those do not have a R compiler can directly use the Google Colab. You can directly go to the Google Colab website and use the R compiler from there.
I'm really sorry for this interruption. So that emergency I talked about, I had to just have a look. So fine. So I hope everybody is able to download R. And I was talking about the popularity of R. Why it is so popular? Because number one, it is free. So it is a blessing for many people, especially in third world countries like India, where expensive statistical analysis softwares, their institutions are not able to provide. So this, and you are forced to use cracked versions, which may sometimes lead to problems of copyright, etc., which is not ethical also. So R allows you to use a valid, legitimate software and actually be able to do almost every kind of analysis in research and statistics that you wish to do. So that is the power of R. So if it is so powerful, then there must be some drawbacks, right? So it is so powerful, it is so free. I mean, it is completely free. So I mean, there are no free lunches in the world, right? So the drawback of R is that you have to learn to do some small bit of programming. That is the, I think, in my opinion, one of the biggest drawbacks that R has. It's not really a drawback. I mean, you need to just have some patience, and with a little patience, anybody can teach himself or herself that much of programming which is required to run it successfully. So I would encourage you personally. I have been using it for almost 12 years now, and because my institution at that time could not provide me expensive software, and then I was motivated to learn this. It was initially a painful process. That time these kind of FDPs were not there, and but the effort that I put at that time, it is still paying me, and I'm hoping that it will continue to pay me in the long run. So I would encourage you all to invest some time. A lot of videos are available on the internet. A lot of free courses are available where you can teach yourself R. A lot of great books are available freely on the internet, which can help you teach R, and no programming background is required. So I hope with this small introduction of, can you please mute yourself? Uh, Friends, please mute yourself. So with this small introduction about R, I hope you will be motivated to learn it. Can you please mute yourself?
Participants, kindly keep your mic off. I repeat, participants, please keep your mic off.
Thank you, Dr. Rajina. Okay, now let me talk about this interface. There is some background noise. Can
Participants, Swati, Miss Swati, can you keep your mic off? All the
hello? I think mic is still on, unfortunately.
yes, sir.
All right, thank you. So, okay, how this interface works. So if you can see, it has 4 parts. On the left at the top, you have the R editor or R script file, right? This is the portion where you write commands in R. Below this, you have R console, that bottom left. Bottom left is R console. R console is the place where your calculations and your commands are executed. On the right, you have 2 panes. One is the pane where what should I call it? Top right. Yeah, this top right pane lists all the variables that you are creating and their values. And below that, there is a space which stores the plots that you create and some other information. So these are the 4 parts, right? How these 4 parts are used. So we use the top left and bottom left part. Top left is the part where we write our instructions to R. Bottom left is the part where these instructions are executed and they become visible to us, right? Okay, so first of all, how does R work? We'll start with a very, very simple and basic example. So in order to do anything in R, you have 2 choices. Either you write your instructions at the top left here and then execute it. Execute means you transfer your instruction from this file. This is just like a Word document. It has no computing power. You are just writing, it's like a blank page, nothing else, right? So once you have written it here, you can then transfer your instruction to R, which is at the bottom left, right? And here R will interpret your instruction and execute it. So that is how it works. Very simple. So let us see. Let us take a very simple calculation. So think of R as a giant calculator. So what do we do in calculator? We do, let us say we want to do 2 plus 2. So I hope you are able to see I have written 2 plus 2 at the top and my cursor is still blinking. I would encourage you to work with me so that you also are able to, remove that fear which comes when you approach a software like this. It's very simple. You will become very quickly very familiar with it. So I have written 2 plus 2. My cursor is still blinking. So remember, what did I tell you? That it is like a blank page. In this blank page, whatever I write gets written. Nothing happens, right? Now, my job is to transfer this instruction 2 plus 2 to bottom left, right? Where the R engine is, sitting. Where the R engine is sitting. And once this instruction is transferred to the bottom left, then R engine does whatever instruction I have given. So the question is how to transfer this 2 plus 2 at the top to the bottom. So how to do that? So after you have written your instruction like this, 2 plus 2 I have written. Now I will press Control Enter. Control Enter. And when I press Control Enter, if you notice, this 2 plus 2 has come in this R engine part, that is the bottom left part, and the solution of 2 plus 2, which is 4, is also displayed in a different color here, right? So can you see this, everybody?
Yes, sir. Yes, sir.
Yeah. Okay. So it's very simple. Let's do something else. Now let's go back to our blank page. This is called R script or R editor. So I go back to the editor and I write 3 minus 2. 3 minus 2. You can write anything. Again press Control Enter. So you see at the bottom, you have got the result 1, the instruction as well as the result, right? In fact, whatever I am writing here, I can do it directly in the bottom left portion also. That is the R engine also. This is actually called R console, right? So this is bottom left is console. If you can carefully listen, then you can remember it easily. The bottom left is R console and top left is R editor. So I'm writing now in the console directly 2 plus 2. Press enter. So see, again the same thing can be written directly. Now you will ask, what should one do? Should one use the editor or should one use the console? So the answer is you should use the console. Why? Because console allows you to edit whatever you are writing. So I am right now giving you very simple examples, but as you become a little more advanced in your journey in R, then you will write codes and programs which will be a little longer, much longer than what we are seeing right now. And there, after you have written it, you might be required to make some changes. If you write something in the script, you can always change it. For example, I'm changing this 2 plus 2, I'm changing backspace to 2 plus 4. And then I'm pressing Control Enter. So see, now the 2 plus 2 became 2 plus 4. But if I want to change something written here in the R console, it is uneditable, right? If I try to edit this, by pressing my mouse, it will not be editable, right? So the good practice that you should learn from the beginning is that you should try and write your code in the R editor or R script. So that is point number 1, right? So these are some examples that I have taken to show you the power of R. Let's take one more example, 8 by 2. 8 by 2. So then again I press Control Enter and I have got 4 as an answer, right? Okay, so now what else can it do? So this is just an introduction. Now we are going to talk about how we can store data in R, right? So R has, R allows you to store data in a number of ways. So the most basic way in which you can store data in R is called a vector, right? So we will just see that. But before that, in R, you can give a name to anything that you are doing. So how do we give a name? So suppose there is a value 2 and I want to give it a name X, right? My purpose is every time I use X anywhere, R should be able to interpret it as 2. That is my purpose. So I want to represent 2 by the symbol X, right? So how can I store any value or a set of values to a simple single name? So the name in which I'm storing the value to is called a variable, right? And the value is of course 2. So here we are talking about a variable which is X and a value which is 2. Remember, it is not necessary that the value should only be a single value. It could be a set of values. So suppose you collect data about something, some phenomenon, like income of people over 60 years of age in your locality. So all the people whom you have surveyed, you have coded them as 1, 2, 3, 4, 5. So that all entire 1 to 100, let's say you've taken a sample of 100. So that 1 to 100, their incomes, their ages, etc., 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 can taken together be stored as a variable, and individual items can also be stored as variable. So we will see. So let's experiment. So I am giving name X. I have typed X and I want to give the value 2 to X. How do we give any value to any variable? So for that in R, we use something called assignment operator. And how does assignment operator work? It works as less than sign and dash sign. So if after any name, you put these two, right? It looks like a left-handed arrow. If you put these two, then R understands that the user is trying to give some value to this particular variable. What is the variable here? X. We are trying to give value 2 to X. How do we connect the value and variable? We use a symbol, as two symbols actually. less than sign and dash. This combination of less than sign and dash is called an operator, and in this case it is called an assignment operator. So after this operator I am writing 2. So x less than dash 2, and then I press enter. So you see exactly R has repeated whatever I wrote in the editor to R console, right? Can you see that? So now x is assigned to 2, right? X name, the name x has been assigned to the value 2. Now if you anytime want to retrieve this x, you will be able to get the value 2. Let us try. So now I am writing here x. If I write x and press enter, press control enter, so you see R is telling me x is equal to 2. So you did not type 2, you typed x, but now R is showing you the value that is hidden behind x, that x represents, right? In fact, if I want to do some operation on x, I can do that. Let us say I want to do x to the power of 4, x to the power of 4, and I press control enter. So I will be getting the answer 2 to the power of 4, right? Now let us assign another variable here. Let us say there is another variable y, and again using the assignment operator I am giving it value 5. So I press enter. So now you have two variables, and if you notice on your top right, these two variables are appearing now, x as 2, y as 5, right? So now you can do some operations on these variables also. How? So x plus y. I am doing x plus y. So see, I did x plus y, and the answer in the console is coming as 7, right? Okay. Now you please play with x and y for a minute on your own. Do x multiplied by y, do x by y, do x square plus y square. Play with it for a minute, right?
We can also use equal symbol, right?
I'm sorry?
We can also use equal symbol to assign
No,
value to
no,
the
no, no,
right?
no. Equal symbol is not used for assignment, right? Although if you do it, you might feel that it is working, but it creates a number of problems, which unfortunately I cannot discuss today. We do not have time. But never use equal sign for assignment operator. Equal is actually a logical operator in R, right? So that is why it is not used. So never use it.
Uh, what happens if we use it double, I mean twice? X
Yeah.
is equal
So
to is equal to 2.
yeah, so as I said, x is the equal to and double equal to are logical operators, right? They are not assignment operators. So when you are using equal to or double equal to, R is interpreting it as a logical operator. For example, if I write x is equal to y, let me go to my screen again. Yeah. So let us say I am writing x is equal to y, right? Now you see the value is coming as false. Why false? And when does false value comes? False value comes when there is a logical question. Logical question of the form whether something is true or false. So by writing x is equal to y, you have asked R whether x is equal to y or not. And R is telling you no, you are wrong. X is not equal.
Okay.
Okay, so I hope everybody is able to, do these small things, and you played with it, x square plus y square, things like that, right? Now, so now two things I'll just summarize. What we have seen.
ಮನೇಲಿ ಒಂದು 1000 ರೂಪಾಯಿ ನೋಟ್ ಇತ್ತು ಹೌದು ನಾನು ಯಾವಾಗ್ಲೂ ಕ್ಲೀನ್ ಮಾಡ್ಬೇಕಂತ ನೋಡಿದೆ
Can you please
ಅದೇನ್
mute
ಮಾಡಕ್ಕಾಗಲ್ಲ
yourself?
ಬಿಟ್ಬಿಡ್ಬೇಕು
Friends, can you please mute your mic?
Participants, kindly keep your mics mute.
Okay, thank you.
Continue, sir.
Yeah. So now, friends, what we have just seen, the assignment operation. assignment means giving a value to a name. That name is called a variable. We use two names, x and y, so they are actually variables, and they actually stored two values. X stored the value 2 and y stored the value 5. Now let's move a bit ahead. So we can store more values than one. I think I mentioned it, right? Now let us try to store a number of values under x, right? How do we do that? So in R, so first you decide what name you want to give to your values. So let us say I want to give the name x itself to a set of values, right? So I write x and then the same thing, assignment operator, less than and dash, less than and dash. And let us say I want to give the values 1, 2 and 3 to x, right? So how can I give these three values together to x? So the way to do in R is we use the C operator. So I write C, then bracket, then I write 1, comma 2, comma 3. You see the way it is written? Now C means you are actually putting together some values. So C and brackets, right? So this is an enclosure you have created around your values, and within that enclosure you have written three values. Why three values? Because we are just hypothetically looking at an example. Now I press Control Enter. So remember, anything you write at the top, it has no effect unless you have transferred it to console by pressing Control Enter. So I press Control Enter, and you see by pressing Control Enter, the same thing has been repeated. Now if I want to retrieve x, so I write x, press Control Enter, and if I do that, R is returning me the values 1, 2 and 3. 1, 2 and 3, right? So let us say I want to, you can create another variable y. Please create another variable with some hypothetical values. So let us say I am creating a variable y, and this time I am using A, B and C, right? So instead of 1, 2, 3, that is numbers, I am using characters, right? I press Y. So you see R has given me an error. It is saying object A is not found. What it means is the moment I want to give a character value, right? Then unless I have told R that it is a character value, R gives the error. So why does it give an error? That I leave it to you as an assignment. After the session, you can Google it. Right now, if we want to give a character value, alphabetical value, then we need to put it under quotes. So if I put it under quotes, all the values separately, and then press Control Enter, now R has accepted Y variable also. And now if I write Y, then R will return ABC. Now if I write X, what does it return? Now notice, in case of Y, it is returning ABC under quotes, and in case of 1, 2, 3, there are no quotes. If you see your right hand side, now the definition of X has changed. So you remember, in R, every time you use a variable name in a fresh manner, the earlier variable definition gets erased, and whatever is the latest variable definition you have given, R only remembers that. Earlier we had saved X as 2, but now we have saved X as 1, 2, 3. So R has removed the earlier definition and is now accepting X as set of 1, 2, 3. Okay, I wanted to point out that you see X is being described here as NUM, which is the short form for numeric. So R has interpreted that X is a numeric variable, right, which has numerical values like 1, 2, 3. Whereas the Y variable is shown as CHR, which is the short form for character. So it is R is telling you that remember Y is a character variable, right? Character vector actually. So these set of values, are called vectors in R, and they are the basis on which the entire, power of R is based upon. So everything that we do in R is actually being done on vectors, right? So we have created two vectors here, X. Now vector has no dimension. So like when we store data in Excel or some other software, usually the data is in the form of a rectangle, right? So there are various columns and number of rows. Here there are neither any columns nor any rows. It's just a collection of values in a particular order, right? That's it. So these are called vectors, right? Now let us try to create another vector Z as C 5, 6, 7. So now the Z vector has been created, and if I type Z and press enter, these values will come, right? So now we have three vectors, X, Y, and Z. R allows us to combine these vectors. And when we combine these vectors, we can create new kind of data types. So we have just discussed first data type in R, which is called a vector. The second data type that we can use in R is a matrix. The third data type that we can use is called a data frame. Now let us quickly look at an example. Okay, before that, let me also tell you that in R there are various functions that you can use. So suppose we want to find out the mean of X, right? So in R there are pre-built functions. These functions can be applied to either values or to variables. How? So let us try to, use a function here on X. Suppose I am interested in finding the mean of X. So how do I do that? I write mean. There is a function called mean, and when you type mean will automatically appear. Press tab and then write X and then press Control Enter. So if you do this, the function mean has been called by you to work on variable X. So the function has worked on X and given you the value. Suppose you want to know the highest value in X. So there is another function called max. I write max X and I press Control Enter. Sorry. And this has given me the maximum value. Okay, just to summarize, we have discussed the data types in R. First one is vector that we have discussed, and we have just discussed functions in R. I have given you examples of two simple functions. There are many functions, like there is standard deviation function and so many in statistics, mean function, median function. I mean, a number of functions are there, right? Okay, so now let me also show you another data type which is more useful to us. So another data type is a matrix, right? Let me create a matrix now. So how do we create a matrix? We create matrix by the function matrix. So now the matrix that I am going to create, I will give it a name, right? And by the way, whenever you are using functions, functions require some inputs. Like for example, the mean function required the input X for what you want to compute mean. Max function required an input. So there are functions which require more often than not, more than one inputs. These inputs are in the language of programming are called arguments. So functions require argument, just keep that in mind. So now we are trying to create a matrix. Let us give our matrix a name. I am giving it a name XY mat. This is a random name I have given. You can give any other name. XY mat is a name I have given, and this name reflects the fact that I am creating a matrix with the help of variable X and Y, right? So what I am doing, XY mat. The function that I am going to use is called a matrix function. The moment I type matrix, it is representing a function in R called matrix. And the moment I type it, R will show me the arguments that this function requires, right? So what arguments this function requires? This function requires First argument is the data. Which data I want to convert into a matrix. Second argument it requires is how many rows I want for this matrix. So the default values are already pre-written inside a function. So if you don't give any value, R will assume that you want a single row matrix. Similarly, if you don't give any value, R will assume that you want a single column matrix. Then another argument is whether you want the values to be filled by row or by columns. And the last argument is whether you want to give any names to the dimensions. So I hope you remember matrices have dimensions, right? Rows versus columns. So let us try to create a matrix here. So the first argument is data, right? What data we want to use? X and Y. So now the problem is X and Y are two different variables. So we first want to combine X and Y. How do we combine X and Y? So first I will start with a bracket and then I want to use the first argument, which is data. How do I combine? So combination of variables is done again with the operator C. How do I do that? C, then again bracket X comma Y. Okay, and then comma. Okay, what I have just done, I have started using function matrix. The first argument it required was data. What was my data? Data was X and Y. Now X and Y are two different variables and I needed to combine them. So for combination I have used the operator C. C will be combining X and Y. So the first argument has been supplied. So each function, if there are more than one arguments, these arguments are separated by comma. So Cxy is the first argument. Then the second argument was n row. How many rows I want for data? Let us assume I want 2 rows for my data, right? And suppose I don't want to give any other value to this function. If I don't give any other value, then R will use the default values of this function, right? So let me stop here because I don't want to make it look very complicated and give you the result of this. So what I did, I ended the function and I press Control Enter. Now this command has repeated here, right? Now let me see the outcome. Outcome is stored in what? It is stored in the variable name called xymat. Can you see? It is being shown here as xymat. So now let me write xymat and press enter. And the moment I do it, I see that now I have a matrix. And this matrix is exactly how I instructed. I instructed 2 rows. I have been given 2 rows, right? Now, can you notice a problem in this matrix? Anyone?
What if the lengths of those two are different? What if X is of different length and Y is of different length?
Yeah, so in that case, R recycles the small vector and keeps repeating it unless it can reach the length of the longer vector. But that was not my question. You are asking me a little advanced question. For the audience to whom I am presenting, I am assuming they know very little about it. So my question again is, what is the problem that you are seeing here?
So there are actually
Data
3
types.
columns are coming. By default,
All
one
the
column.
values are character value.
Yes. Who said the character value?
Yeah, this is Dr. Taranjit.
Yes, Dr. Taranjit, you are absolutely right. You see, now all the values that are coming as an output, they have quotes. And we just discussed that quotes, any value being shown in quotes means it is not a number, it is a character. Although we had given x as a numerical vector, but the result is having all character values. So if our data was numerical and by supplying it into this form, the numerical values become character, we won't be able to perform any calculations on them, right? And this is the reason. And first of all, why it has happened? Why it has happened? Matrices can store only one type of data. Always remember, in R or anywhere else, matrix structure can store only one type of data. So if you are giving it two types of data, I have given it numerical, one vector x which was numerical and one vector y which was character. It has converted the numerical vector also as character vector, right? So this is a problem. So then what to do? So is there any help? The answer is yes. Now let us define a new data type. So we discuss one data type vector, combination of vectors, matrix. Now we found the problem in matrix. Matrix cannot have more than one data type. Now we are looking at a data type which can give us the kind of data that we are supplying it, right? So these are the actually not data types. I'm using the wrong term. It is called data structure, right? So let me give you another data structure which is going to be your friend if you plan to use R after this session for your research. So this data structure is called DF data frame. So I'm giving a new name XYDF, and then assignment operator, and then I'm using a function called data.frame. Data.frame.
Sorry to interrupt.
Yeah.
I have one more question in the matrix structure.
Yeah.
So what if I want X in the first row and Y in the second row? Because in the output we got, it is 1, 3, B, and B is of element. B is the element of the vector Y, right?
Yeah. What's your name, please?
I'm Pavan.
Sorry.
Pavan.
Yeah. So Pavan, if you noticed how R has used your data. So it started with the first vector, first value. First vector was X and the first value was 1, right? So it started with that. Then it went down, used the second value of the first vector. Then again, since we exhausted the rows, it went to the third value of first vector. Then first value of second vector, second value of second vector, third value of second vector.
Yeah.
Now
So
what
the alignment is by rows, right?
it is filling the matrix column wise, right?
Yeah, column wise.
Now if you want to change that, so we can do that and we write by row is equal to false. Sorry, it has done row wise. So if I write okay, let me check. Let me just check. Yeah, so what it has done is it has filled the elements row wise, right? First row, second row, then first row, second row, then first row and second row. If you want to change that, so you write by row is equal to true and then get the matrix, and then what you will get? Now you see, now it is filling the matrix column wise, right?
Yeah, got it. Thanks.
Okay. Okay, so now I was telling you about the type of data structure which is going to be most useful to us as researchers. So I am writing a name XYDF, and now I'll use a function called data frame. This function has a number of arguments, but this does not require you to identify rows, columns, etc. Because data frame is not a matrix, right? It looks like a matrix, but it's not a matrix. It is a collection of vectors, right? It is a collection of vectors. So I write data frame, then first vector and second vector, right? And then press enter. So let us see the output XYDF. I'll type again. And now if you see, you got a nice matrix like structure where the first column has a name X and it has the value 1, 2, 3 exactly in the form that you wanted, right? And it has the second column Y named Y, and it has all the values of A, B and C that you have given it, right? So it has not forced the numeric values into character values, right? So this will allow you to use the value in the first column in whatever manner you want. Now if you are wondering how this matters to us, so oftentimes when you are collecting data, then data could be of nominal type or of ordinal type. Often in nominal type and ordinal type, you might be using some symbols to store data, right? For example, you might be using yes, no, or you might be using M, F, male, female. All those things has to be stored. They are not numeric values, right? They are character values. So first you need to understand they are character values. Now, if they are ordinal data, right? I mean, they are categorical data. Then in categorical case, you would like to use them as categorical variables, right? So having this understanding that different columns in a data frame can store data of different types will allow you to handle your data in a correct manner, right? Okay, so friends, what we have done, we have just seen three data types. Vector is the basic building block. From vector you can get a matrix. Matrix had a problem. It's not that matrices are useless, but for now matrix we saw a problem that it cannot store multiple data types. And the third structure that we saw was the data frame where multiple data types are possible, right? Okay, now with this much understanding, let me now discuss a bit about the real power of R, where the power of R comes from. So this software which you have downloaded on your system, this has some basic, although the basic itself is quite vast, but it has some basic functionalities, right? In case of R, there are many people around the world who develop various tools to be used on R. What do I mean by tools? These tools are nothing but a set of functions. So suppose there is a what should I call it? Sports scientist. So that sports scientist might develop customized functions which can be used on a cricket match data, right? And those functions he can develop by creating R programs, right? And across the world, if he feels that he wants anybody and everybody to be able to use it, that collection of functions he can put on the R server, right? He does not directly do it, but it can be put on the R server and any user of R around the world can use it. This collection of functions which is created by some computer programmer or developer or user maybe sometimes is called a package, right? Package in R is nothing but a collection of functions which can perform some particular tasks, right? So there are packages which help you with normal statistics. There are packages which allow you to use mathematical statistics. There are packages which allow you to do time series analysis. There are packages for finance. There are packages for economics. There are packages for weather data. There are packages for sports data. There are packages for social media data. There are packages for text analysis. Almost anything that you can think of in research, fortunately, a free package is available. Now, how to know which package is useful? So gradually you will see Google you can take help from. R has a website, it is called CRAN, right? Comprehensive R Archives Network. You can Google CRAN and it will take you to that site. After this session, please spend some time on that site. It has a list of packages which perform some typical functions, right? Second question is how we use these functions. So as I said, right now, if I want to use a package, that package is not here. That package is sitting in a computer where the R has hosted that package. The R network, R consortium has hosted that package, but I have the ability to download that package in my system, right? So how do I do that? So for bringing a package into my system, now, if you are finding it difficult to understand, think of it like this. The R server is like a library, right? And you are a user. So you want to get a book from the library, you go to the library, get the book and bring it to your room or your office. You put the book there and anytime you want to read that book, you can just pick it up and read it. But for being able to pick it up and read it, you need to bring the book, right? So the package is like a book. It is in the library, that is our consortium server. We have the ability to get that book issued to us. That book will come to our system, and anytime we want to use it, we can pick it up and use it. So let us, for today's session, I would like you all to download a package which is called AER. It is Applied Econometrics with R, right? So how do we, download a package? So there is a function called install dot packages. Now remember, R is very case sensitive, so you need to be absolutely sure about the spellings that you are using. Install dot packages, and under quotes I am writing AER. AER. So why now you might be wondering what is AER? AER is a package developed by authors of a book called Applied Econometrics with R. Why we are downloading this package? This package has number of examples which we can use in this session and train ourselves about various research tools in econometrics, right? So
Dr.
after I,
Agarwal,
yes,
before
please.
we move forward, I just want to, it's like a question, but also for understanding. If you want to simplify whatever we have discussed for like last 1 hour, uh, the R, and then we started that, it's like a big. I'm just reiterating what we studied in 1-2 lines. Help me understand if I got it correct.
Yes.
So R is like a big calculator, and where we all these inputs like uh, whether it is metrics or vector or data frame, it's like languages that this calculator is using, and we are using this language to have to solve functions or to solve problems. And this indirectly helps us in research problems. And using, and these packages which you mentioned are like set of books or libraries which we can work upon by ourselves, or these are already formed and we can directly use them. Again, the purpose is to do research. So
The
am I
purpose is
getting
to
the
do,
basic?
yeah, you, to a large extent you are right. Some correction is required. So these data frame and metrics that I mentioned, so they are not languages. They are the structures in which data is stored. This will become clear to you in a short while, don't worry. But largely you have got it right. These packages are set of functions which you can apply on your data. You don't do research with R, you do data analysis with R. Research is a much broader and wider term, right? Research requires problem formulation, then deciding upon which tool to use to analyze data. Data analysis is just a part of the entire research process. R does not do research for you, R does data analysis for you. So you have got your data, you want to apply regression, you want to apply factor analysis, you want to apply some time series analysis, right? Vector auto regression, arch garch models, you name it, any model that you wish to apply. But that decision, which model I need to apply, that is your decision. R cannot take that decision for you. R can only do what you tell this, right? But R will not be able to. So R is like a servant, right? I book a cab and I cannot ask the cab driver to take me to a place. I have to tell that cab driver that take me to Connaught Place, take me to Lodi Road, right? So this is what R does. We have to tell R that okay, you do this, but what R has to do, we have to decide and tell R. Okay,
All
Mr.
right.
Taranjit, got it?
All right.
Okay, so now we are giving you a demonstration of one package called AER. So remember, when you want to download a package, this is the function install.packages, and within brackets you write the function name. The package name. So this package has a name AER and it has to be always written under quotes. Now I am pressing Control Enter, and when I do that, you see a download process will begin. And finally you will get a message, package AER has successfully unpacked and MD5 sum. So R has downloaded this package successfully. Are you able to do this? Will anybody confirm? Friends, are you able to do this?
Yes, yes.
Yes, sir.
Okay. Now you have got the book issued from the library, right? So this package is now from the server of our network has come to your computer system. But it's like getting the book issued and putting it in the Almira. It is right now lying in the Almira. If you want to read it, you need to take the book out of the Almira and bring it to your table. So now this package is in the Almira of your computer. So in order for any downloaded package to be used, first is you download it. After downloading, every time you want to use it, you have to call out this package. How do we call out? There is a command called library command. So we write a function called library function, and in library function we write the package name. So see, we are using the package twice here. One for download. Download means permanent. Now it will be in your system unless you delete it. Second, it is living in my system, but I want to wake it up. Come work for me. So for doing that, the function is called library. So I write library, and now I don't have to give quotes because now this package is already in my system. I don't have to give quotes. I press Control Enter. So when I do Control Enter, this package and all its contents become immediately available to me. So whatever is there in the package, it will become available to me. Now you might be wondering how to know which package has what features, what all it can do, and how you can learn it. So fortunately, R has mandated that all packages, the writers of those packages, the programmers, have to create a help document for all packages. So for example, go to Google and just type and these help manuals are called Vignets, V-I-G, Vignets, Vignettes, Vignets, right? I'm writing it, Vignets, right? So go to Google and just type R package AER Vignet, and you see what the result comes, and tell me R package AER Vignet. So for package AER, you are looking for a help document. Can you tell me what result you got? Did you get any result?
17 vignettes.
Yeah. So you can, maybe the first result might be most relevant. So that will contain all the details of the package. So I wanted to just tell you how to take help because you will be on your own journey, right? And this is how you can teach yourself. Now leave that Vignette part aside. Come back to what we are discussing. So now this package has a number of example data sets, right? Example data sets, and one data set that this package has is called journals, right? So if any package has an example data set, we can access that data set by its name and by using a function called data. So I am using the function data, and now every function requires an input, right? One or more inputs. Which input it requires? It requires the name of dataset. So the name of dataset, since I already know, is journals dataset. So the moment you will type JOUR, R will give you a prompt that, and it is giving you a description also. Economics journals subscription data for the year 2000, subscription to economic journals at United States libraries, right? So I just tab it, right, and I press Control Enter. Now nothing has happened. Why nothing has happened? Because the data set has been opened, and this data set has a name called journals. Now in Excel, and if you see your top right corner, you see this data set is being displayed here. Journals data set name is here, and they are telling you that this data has 180 observations of 10 variables. 180 observations of 10 variables. Now, people who use Excel, they can see the data in front of them whenever they, type some data or open a data file. But here this data is not automatically visible, though it is there now on your screen. But in order to see your data, you have to use friends, I'm telling you some very important functions. Please make a note of them. When you have loaded any data on your system and you want to see it, the first function that you use is called head function. So head function, I am writing head, and here I am writing the name of the data. So head journals, the name of the data is journals. I don't have to use quotes now because already I have it in my console. So head journals, and when I type head journals, you see R is displaying the data in the console. Can you see? So the description was 180 observations of 10 variables. So this data has number 1, the codes of journals, number 2, the title of journals, second column, third column is the publisher of journal, fourth column is the society, whether journal is published by a society, fifth column is the price of journal, then pages of journal, how many pages, character per page, citations, founding year, subscribers, and in which subject area this journal is specializing, right? So now you are able to see first
Sorry to
first
interrupt.
6 rows of data. So the head function lets you see first 6 rows of data. Remember that. The next function is to see all these data. What are the types of these data? Are they numeric data? Are they character data? Are they some other type of data? So for that, there is a wonderful function in R. It is called str function. Str function. So str function, str journals. What does head function do? It displays first 6 rows of data. What does str do? Str displays the types of data, right? So I have written str journals and control enter. Now see, I have got the summary of all my variables. So first column is title. It is the type character and it is giving some examples. Second type is publisher. It is a factor data, what you call the nominal or category data. So factor, it has 52 levels. Yani different press names are there and they are being shown as category. Whether the third column, society, what is the data type? It is again a category data with 2 levels, yes and no, with 2 levels. So yes is being showed as 1 and no is being showed as 0. Price data, price column is integer data. Pages column, integer data. So all field column is now again a field of category data with 24 levels. So 24 different categories are there under field. So now you are able to see that your data which you have collected in different columns, and this is how it will look like when you actually do a research, right? Isn't it? You will have different columns for different variables.
What is
right?
factor? What is
Yeah.
factor type?
Categorical data is named as factor data in R, right? So what we know as categorical data in R's language, it doesn't call it categorical data, it calls it factor data. And the number of categories is called levels. So for example, in society, what are the number of categories? There are only 2 categories, right? If you see, let me do head journals again. So if you see society, yeah. So society has no, 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 and somewhere down the line it will be yes also. So under the column society, you have recorded the data as no or yes. So this summary which you got from str function, it is telling you that under column society, the data is stored as categories with 2 categories, and these 2 categories are no and yes. Did you get it?
Yeah.
Okay, great. So now the next thing, once we have our data, what do? We generally do some exploratory data analysis to see how my data looks like. Now in R, you can do now. So this data has a number of variables. So what we can do is we can create a subset of this data by selecting only one or two variables. So I will select two variables, and how do I select it? So I will create a new variable, and this variable I will name as CMR, because CMR University is organizing this FDP. I'm giving it the name CMR. And now, friends, what I'm discussing a very important tool in R, which is called subsetting. What I'm doing, I have a, acha, by the way, I forgot one thing. Let me do this str again. Str, so running show. Now, friends, see here. What do you see? What do you see?
It is of the structure data frame.
It is of the structured data frame. Now I think you can connect why I was discussing data frame. So this data frame has 180 observations of 10 variables. That means there are 10 columns, right? And each column is housing a different type of variable. Some column is having character variable, some column is having a categorical variable, some column is having a numeric variable. And this is exactly how our data, when we do actual research, will also look like. So now I think you understand how data frame comes into picture and why it is so important and useful, right? Now,
One more question, Pankaj.
yeah,
So a column can have different data types, right?
yeah. So there
One
are,
column.
different data types. One is, of course, numeric. So numeric will allow decimal values also. Then you have integer. Integer will not allow decimal values. Then you have factor. So factor will have levels, that is categories. Then you have simple character data, which is just a nominal data, right? And I cannot think of any other data type. Yeah. So
So how
these
do I check the data type of a column?
data type of a column, very good question. So how you can check? So first of all, you need to be, either you can use the str command, and str will give you data type of all columns, right? And if you are interested in a particular column only and you don't want to run the str command on the whole data, so you can subset that column. How to subset that column? So to subset a column, you can use the name of the whole data and then use dollar sign and then use the column name. So let us say I am interested only in price, right? So what I do, I create a variable called price, PRC I am giving short name, PRC, and I am subsetting my original data, which is journals, and this data I want to extract which column? I want to extract the price column. So the moment I type a dollar sign after the name of my data, R will display all the column names. So it is displaying first column name, title, publisher, society, price. Now let me select price. Now you see what I have done. I have taken the data set, used a dollar sign is acting like a hook. So on that data set journals, I am using a hook to extract a particular column which was titled price. And when then I press enter, nothing will happen because this price data has been stored with a new name called PRC. And now I am interested in knowing the data type of PRC. So I can do that. There is another way I can do that. Class function PRC, and it will show me the data type as integer. Is that fine?
Yeah, good. Thanks.
So str, you can subset the data. Okay, now let us,
Is of the class.
How come you're typing in the console?
you can type in the console as well. I told you in the beginning. The problem is if you
Okay.
type in console, you cannot edit whatever you have typed, right?
Okay.
Yeah.
Yeah. Do we have a function to remove a column, particular column, like as you extracted a column? I mean, you
Yeah,
subsetted
yeah.
it.
Yes, yes. So you have the option. So first, let me go to how to select a particular column that I have shown you, how to select more than one columns, right? So let me create a new data set, subset with only the columns, the subscriptions and price, right? How do I do that? So in R, the square bracket is used to subset data. Square bracket has a comma inside it. Before comma, you can name the rows, and after comma, you can name the columns. You can name the rows and columns either by index or by the column name. Let me show you. Let me show you. So let us say I want to subset these data journals and I am interested in two columns. So, how many columns were there? If I want to check, so there is a function called call names function. Call names function, if I apply to the data journals, will give me all column names. So friends, this is another function, very useful. You can note down. Now, it has displayed all the column names. I think somebody's mic is on. I request the participants to please show some courtesy towards your fellow participants. You may not be very serious about this discussion, but there may be people who are very serious, and a little carelessness from your side is disturbing everyone. So please show some respect, some courtesy to the fellow participants, and please mute yourself. Yeah. So call names is another very useful. So I have seen it has two columns. One is called subs and one is called price. I am interested in extracting these two columns and create a new database, smaller database. How do I do that? So let me say I am giving a name. Let's say okay, CMR again. CMR. Okay. So CMR is a subset of the journals database. Now I want to subset what? Journals. So first I will write the name of the original database, journals. Then I want to subset. So I said you can subset by $sign if you want to extract a single column. But now you are interested in extracting two columns. So the way to do is with the help of square bracket. So when you get square bracket and then press comma, now you are instructing R to extract some rows or some columns from this data called journals. This is what it means. Whatever is displaying on your screen right now, it is telling R that I want to subset some rows and some columns from the database journals, right? Now, which columns and which rows? So if you are interested in all rows, but only two columns called subs and price, then you leave the row part vacant. So I leave this space before the comma vacant. If you leave this part vacant, you are telling R that see, I am interested in all the rows. So I am leaving it vacant. Then you use the arrow key and come after the comma. Here you can write either the column names or the serial number of columns, and R will be able to extract it for you. Let us first use the names of columns. So I am interested in price and subs. So both the names I can use with C operator under quotes. So I write price and subs, right? Can you see the syntax here? The data set name is here. After that there is a square bracket. In this square bracket there is a comma. Before the comma, space is for rows. After the comma, space is for columns. So I want all rows. So I used blank space here. After the comma, I want two particular columns, price and subs. So I wrote their name separated by a comma with C operator. Every time I want to combine any things, I mean more than one thing, I need to use C operator. And I press enter. If I press enter, nothing will happen, but here the variable will be displayed as CMR. Now you see 180 observations of two variables. So this is what we wanted. We wanted the two variables and all observations. The journal's data had 180 observations of 10 variables. And this data set is a chunk of my original data. It has only two variables. Now let me use the head command to just display my data and make sure that what I wanted is here. So head CMR, and you see now it is showing me only two columns.
So the structure is same, right? Data frame, right?
You check,
Or
you
is
check,
it-
you check. Now you have the tool to check it. STR CMR. STR CMR. Yeah, structure is data frame, and now it is displaying the data types under price column and subs column, right? So I'll quickly summarize. We have taken a large database, we have subsetted two columns, right? So now suppose we want to check how our data is distributed, right? So let us check it. Let us check it because both the data types of integer, oftentimes we want to check the distribution of our data. So in R, how do you check the distribution? So there is a function called summary function. So you write summary and the data set name, summary CMR, and enter. So when you write summary CMR, the descriptive statistics comes in. So for the price column, it is giving you a 6-point summary, the minimum value, the maximum value, so you can get the range, first quartile, third quartile, median and mean. So you see median is much lower than mean. So that means data is definitely not normally distributed. Here also you will see the median is much lower than mean. So the data is not normally distributed, right? So now you are able to get a better feel of your data, how your data is distributed. Sometimes we want to do exploratory data analysis with graphics also. So in R, we can plot the graphs of these two data. I mean, this data is one CMR. It has two columns. Suppose we want to plot a histogram of the price data. So there is a function which is hist function, HIST. Hist function plots the histogram of any data that we are interested in. Now, right now we are interested in the price data. So how to extract price data from CMR? So we will use CMR $price. So if we do CMR $price, we will be able to plot a histogram. So I press enter and you see I have got a histogram. Are you able to do this? Are you with me?
Yes, Pankaj. Yeah.
Only one person is responding. What happened to others?
Yes, sir.
Okay. So now you see your data is not normally distributed. So it is very difficult to use this kind of skewed data in analysis. You agree or disagree? You agree or disagree?
Could you repeat the question, please?
My question is,
Yes, sir.
this data is not normally distributed. Then if you want to use this data in a model, there might be problems. Yes or no?
Yes.
Yeah.
Yes, it's not
Sir.
normal.
It's not normal. So how do we transform our data and make it closer to normality? So one of the simplest transformations that we use when our data does not have negative values is the log transformation, right? So if we take log of this price data, then can we check whether our data is looking more normal now? So let us now plot a histogram of log of this data. So I am using log function on CMR dollar price. See what I have done. Again, hist command is being used, hist function. But inside the hist function, instead of giving the price column, I am giving it log of price column. So if I do log of price column, all values in the price column, the log will be taken and then a histogram will be plotted. So I press enter and see the data has changed. Now is it better looking data for analysis?
Yes. Yes, sir.
Yes, sir.
Yes, sir.
Yeah.
Sir, then there will be no missing of data, sir.
So we are this case. This is an example. This is an example, madam. And in this case, there is no missing data, right? And that is why you are getting straight away. You are getting values. In reality, what will happen if you have missing data, or if you have data which is negative or zero, then you will have problem in log transformation. So in such cases, you can select, there are options. I have very limited time with you people, so I cannot discuss how to remove missing values. So if you think that missing values can be removed safely, I'm not saying missing values should always be removed, that is a wrong practice. But if you think it can be safely removed, then you have the option in R to remove the missing values and then use this kind of transformation. But my purpose is not to teach you transformation right now. There are many other transformations, right? I just wanted to show you, when you start with your data, before actually analyzing it, how should you do exploratory data analysis with the help of R. That is my purpose, and I taught you two functions, one the summary function and the other is hist function, right? If you are interested in finding out the standard deviation of data, that also you can do with SD function. Now friends, time does not permit me, so I will straight away go to the regression of this data. So let us say I am interested in finding out a relationship between subscription and price. And I think subscription is a function of price, right? I have a logic that if price is high, subscription will be lower. If price is low, subscription will be higher. And I want to test whether there is a relationship between subscription and price or not. So the first task is I checked my data. I checked for the normality, presence of normality. I found that price data was not normal. So I did a log transformation. Let me do the same thing for subscription also. So let me plot subscription and see subscription is also skewed. So as it was shown under the summary function also. So I can take log of subs data and see whether it improves the data, improves the distribution of data. Yeah, so the log is improving the distribution of subscription data also. So this has told me that I should use the log of these data. Now I'm taking a very simple example. So let me my theory, my literature review tells me that subscription is the Y variable and price is the X variable. I'm sorry. I want to see whether there is any relationship between subscription and price. So first I can do a scatter plot to see the relationship. How do we do that? So in R we use plot function. In plot function, our variable Y and variable X both can be given as input. How do we do that? So our Y variable is subscription that we have decided. So we write log CMR. Okay. Okay, this is a better way of doing it. So I'm writing subs, and I'm using a special symbol which is like a wave, right? This symbol is found below the escape key. Below the escape key, this symbol is used in R for models. So if I have a model y is equal to a function of x, y, z. So in R, I will write it as y, this symbol x, y, z, right? So this symbol represents model. This is called tilde symbol, tilde. So I use this tilde. Some people call it tilde. So subs tilde price. Right. Now remember, R does not know what is subs and price because subs and price are stored under CMR data. So the plot function has a input where you can specify data. So I have told R to plot, scatter plot subs versus price. Subs is y, price is x. So we write y first, then tilde, then all x's on the right. Then comma, I have to tell R where is my data. So I have told R my data is under variable CMR. Here I will be using equal to sign. So equal to sign is often used inside functions, not for assignment. Then I press enter. And when I press enter, I get a scatter plot. I get a scatter plot, and this scatter plot, because of the skewness, does not really tell me whether there is a relationship between these two variables or not. Right? So this relationship is getting confused because both of my data are skewed data. So we saw that if we take log of these data, the data distribution improves. So let us plot the log of these data as a scatter plot. So log subs log price. Log subs. Now friends, if you are worried that after this session how will you remember all of this, you really don't need to worry. You can go to internet and download number of books which are available on how to use R for econometrics, regression, whatever tool you want to use. With the help of those books, you will be able to do all this which I am doing. Right now, I just want you to get a initial familiarity so that the fear factor is gone. Okay, so I am rushing a bit, I know, but I have no choice. I have to end by 9. I have only exactly 13 minutes to go. So now let me plot. Okay, so can you see some relationship now, friends? Can you see some relationship now?
Yes, sir.
So it is not exactly coming out as a straight off relationship, but it is better than the previous graph. And so you remember, all of you, many of you might be very new researchers. Remember, whenever you are using data in any model, first do exploratory data analysis, see the distribution of your data. If it is not normally distributed, not always, but often, you need to transform it so that you can look at the real relationship between them. Right. So now we have concluded that there might be a relationship. So let us find out the exact relationship. So for that, we would like to run a regression, a simple regression between y and x. Friends, time does not permit me to talk about, regression with more than 2 variables, right? So I will be only talking about bivariate regression. Multivariate regression I will not be talking about, but basic principles remain the same. How do I regress? How do I do regression? So first, let me give a name to my regression model. So let me give a name, mod, reg mod I am giving, reg mod. This is a random name I have given. You can give any other name. Now reg mod, I will use assignment operator. And now I will use for one of the most useful functions in R used for regression. It is called LM function. LM. LM is a short form for linear model. Linear model. So I'll use LM function. And under LM function, it requires some inputs. It requires a formula, then data, then so many other things. So I will not get into other things. I will only be interested in the formula and data. What is formula? So we have hypothesized that our regression is y is a function of x, where y is subscription and x is price. So like we have written in plot, we will exactly write it here: log subs tilde log price, right? And comma. So you see, first input lm function required was what? A formula. Formula means what? The model. How do we write model? We don't write model as y is equal to ax or bx. We don't write like that. We write y tilde then all the x variables, right? If there are more than one x variable, then you can add plus sign between them. Here we are using only one variable. Now, where is the data? Data is in CMR, right? And then press enter. Now what has happened? The regression between the log of subscription and log of price has been conducted. And now we want to see what is the result of our regression. So let us look at the result. How do we look at the result? So there are two ways. You simply type reg mod and enter. So it will give you the result. It will give you the command that you used, and then it will give you the intercept as well as coefficient. As anticipated, there is a negative relationship between price and subscription, right? Because the coefficient of price has come out as negative. Now, for a researcher, this is not enough. We need to do hypothesis testing also, find the significance levels also. So how do we do that? So whenever you are doing a regression, after your regression has been run, the function summary can be used, and I'm using the function summary, and the input will be the reg mod variable. What was reg mod variable? It was a name I gave to the function call for regression. So when I do summary reg mod, what do I get? So I start with the command. The result is giving me the command. Then it is giving me the residuals. Then it is giving me the coefficients. So intercept is 7. Then coefficient is minus 0.41. And then I am getting standard error, the t values and the p values. And as you can see, in case of intercept as well as the x variable, the p values are highly significant, right? And the adjusted r squared is very low. So this might be a concern, that the adjusted r squared is very low. So this is a hypothetical example I'm using. I'm just showing you where you will find the relevant values, right? So now there are many other things that you can do, with R and with regression. So I think time does not permit me. It's already 8:54 by my clock, 8:53 by my clock, and I think I need to summarize now so that we can end on time. So I know it was very, very fast, too fast for my own liking, but we had no choice. But my target was to give you an initial taste of R and its power, right? And uh, once you learn R, friends, I'm telling you by my personal experience, you feel so powerful in the sense that you know that you have the right equipment to do research. Okay, equipment is there at least. You don't have to ask someone for data analysis. You don't have to ask someone for software. You don't have to ask your institution to purchase software and they will tell you that we don't have funds. All of that goes off. Only thing left is how to identify a research problem. So I would strongly recommend you all to spend time in learning R. It looks initially a little difficult, But trust me, I always believe that if I could learn it, anybody can learn it. Only thing is, it requires practice and patience. You don't really require a teacher also. So you can go to various videos which are available, various free courses. NPTEL has number of courses on R. You can enroll for free and you can do those courses. Software is free, courses are free. So then what else do you want? Tell me. So as I said, slightly difficult. You will feel that I am not making any progress, making mistakes. It is a slow progress that you face in R. But a time will come when you will be able to really use it if you are patient enough. So I encourage you to invest your time and energy in learning it. Uh, Also, one another beauty of R is, suppose you are trying to do some analysis and you are stuck somewhere. You don't know how to handle this problem. R has a beautiful user community which puts on internet almost any problem that you encounter and its solution. So when you start learning R, all those problems you will face, somebody has already faced them in the world and they have taken help from others, and these people have helped each other, and it's available on the internet freely. So you write your problem on Google and write in R, end it in R, you will most likely get a solution. I think 99% of the time I have been able to get a solution for the problems that I faced. I still face problems, right? It's a never ending journey, and every time I'm able to get a solution. So if you have some commitment, some patience to work on it, it is a very, very, very rewarding exercise. But it is not a shortcut. It is not for those people who think that I just want to do analysis with the press of clicks. It is not for them, right? It is for those people who want to become a really good expert in analysis, but who are also ready to face the pain of learning a new programming language. It is not exactly a programming language in the sense some other languages may be. It is still very, very easy. You can write your syntax and commands in plain English, right? Most of the time you will be able to do that. So I encourage you to spend time on R, learn more about R, and become a great researcher, right? A researcher who uses the latest tools, a researcher who uses high quality data analysis on genuine software, right? So I think time does not really permit me. I know, I think you will agree with me that it's not easy to discuss such a vast area within 120 minutes, and today because of my crisis another 15 minutes were sacrificed. But friends, I tried my best to give you a taste, and that was my purpose, and to motivate you. I hope that you all will, will be encouraged by this session. That is my hope. I don't know. Teacher doesn't know unless the students tell them. So I only hope that you get benefited by this session. So all the best from my side. Thank you. Over to you, Dr. Rajin.
Thank you, sir.
Yeah.
Thank you so much, Pankaj. Thank you, sir.
I have one question. Sorry.
Professor,
Sorry to interrupt.
one question, sir.
Yeah.
Sir, do you have any modules, sir, for regarding the use of those formulas and all? If you have, please share it, sir.
I can share you links of a couple of internet-based resources which are free. You can download them. They have example data sets. Step by step, they will explain, right? Okay, I think in the chat box, where is the chat box? I think Microsoft Teams, I am less familiar with it now. Let me find out the chat box.
Sir, chat box will not be visible to you.
Oh, acha. Okay.
Sir, because you are not the host. So you share on the WhatsApp. I will share it in the group, sir.
Absolutely. So I will share the link of some freely downloadable resources, and everything that we have discussed and much more will be there. And I want to assure you, you can start as a beginner with those resources. You don't need anybody. You just follow those instructions, practice, and you can get this and much more, much beyond this. Okay.
Yes, sir. Thank you.
Thank you, Pankaj sir. 2 hours have just flew away like anything. No, but people would have not even realized how it has gone because of being a practical session. Sir, on behalf of School of Economics and Commerce, CMR University, I thank you for your gracious presence, sir, to join us today and enhance our joy of learning, sir. And it was really interesting. Hope all participants will accept that fact. And I will propose my vote of thanks on this occasion. I would like to express my appreciation to our resource person, Dr. Pankaj Kumar Agarwal, sir, for joining us today and sharing your treasure of knowledge, sir. Even everybody R is something that is everybody has a big question mark in the mind, but the way you have taken it would have really made things much easy for them, sir. And thanks for sharing your knowledge and making the event adding extra spark to it, sir. And I also want to thank our SOEC director, Dr.B.B. Tiwari, sir, for being there as a supporting pillar behind the session and ensuring the smooth process of the event, sir. Thank you so much, sir, for being there. And I also want to thank all the participants, wonderful participants who have been very interactive and who have been enjoying the session and making it much more interesting. Thank you for that. With this, I will sign off. Dr. Razina from School of Economics and Commerce, CMR University. Thank you, sir. Thank you all.
Thank you, Professor Tiwari. Thank you, Dr. Regina, for inviting me. Thank you, all participants. All the
Sir,
best.
from taking the time from your this busy schedule and this.
Dr. Tiwari is a very old friend of mine, so I cannot say no to him. He knows it. Unfortunately, something happened, so we lost 15 minutes. So, thank you, Dr.
But
Tiwari.
It's your love and affection, sir, towards me always.
We are lucky to have love and affection of each other. Thank you.
thank you, sir. Once again, thank you so much, sir, for being part of our FTP program. Thank you, sir. And participants.